Good day once more, dear students, right? Now in this class now, like there are some considerations that I would like to show you. You see, that are very important whenever we are dealing with what? With this disconnection, approach, with this retrosynthesis, basically. That is things like logic, right? Logic, it's very important. Are you with me? Note that the design itself isn't a feasible design, is it an impossible design, is it an expensive design, how safe is the design that I'm going to take? The question of time, it's also very important. Will your reaction take 30 seconds? Will your reaction take an hour? Will your reaction take 90 days? Right? And then also another consideration is the question of what? Of cost. Right? How expensive is this reaction? Like in terms of the chemicals that you're going to buy, etc., etc., etc. So when you are in the lab, right, you don't just choose willy-nilly. You consider all these things, right? That's very, very important. Now, let us take the very same example like that I gave you in the last lecture. Now, imagine now, like, you've got this alcohol here again as your target molecule, right? But in this case now, like, you are not told that synthesize this target molecule from a certain starting material. For example, like in the last lecture, we said synthesize this from a tertiary alkali halide. In this case now, like the question says, from any starting material. Now, how do you go about this now as a student, right? Remember, as a student, you need to look at your question, right? Identify your question, then critically engage with your question, critically analyze your question. Right? Let's go. Now in this case now, like, what am I going to do? Here, if I look at this here, right? Yesterday, it is this bond that broke. What if it's not going to be this bond that's going to break in this case? What if it's going to be this bond? So, carbon to methyl bond, carbon to methyl bond, this one, all these bonds are the same in this case. Now the question is now, like, what if now, like, it's going to be this bond that's going to break in this case, as opposed to that one? How will it break, right? Of course, this could break in this fashion. This single bond here can break and then give us this type of structure, right? So what will I get if this were to break? I'm just making an example. Then can you see now, like, the arrows that I'm using here, you see, like, it's for what? Retrosynthesis. That's very important. So in this case now, like, it means I will have my OH here, right? And then here I'll have my methyl group, my methyl group, my methyl group. So it means that now, like, here there has been a movement of 2 electrons to this carbon atom. Then this carbon atom, it gives me a negative. It gives me a carbanion, for example, right? And then now, like, what about the methyl group in that case? The methyl group in that case now, like, will become Me what? Me plus, right? Yes. What if something like this happened, right? But no, like, from our knowledge of what we call like basic, what we call like organic chemistry, right? This is not so logical, right? You see, then here I can simply write, to me, like, this is not logical. I wouldn't choose this for now. I would think. Then I would go to another option, another possibility. What is another possibility? What if this bond here now, it breaks to the side, like the other way around, where you've got your methyl group, in that case, right? And then here, you've got your methyl group, you've got your methyl group here, and then you've got your OH here, 1, 2, 1, 2, this, right? Now what if now, like, this bond between this methyl group and this carbon atom breaks the other way around? Is it going to give me anything that is familiar? Anything that's going to be familiar? Let's see. Let's explore. Now can you see here? What will I get here? I'll get this here, OH, 1, 2, 1, 2, 1, 2, 1, 2. This is what here? Methyl group, and then this carbon atom here will become positive because it has lost these electrons. What will become of your Me there? My Me has gone with those 2 electrons, it gives me what we call like an N ion, right? You see, so Me, what we call like minus. Am I familiar with this? Is this logical? Yes, it is logical. Let's trace it, right? Back to first year chemistry. If I look at this here, I've got a positive charge here, a single bond here, and a lone pair. Automatically, resonance structure comes into mind. So it means that this could come over here. So I'm not going to consider it in resonance structure. Then what would I get if I were to go back, for example, in this case? Then here I would get this here. Remember, this is my methyl group. Remember, this is my methyl group. Then it means that here I must have had double bond O here, then H here, this in this case, and then that means that now like the oxygen atom, it's the one that's going to be what? Positive in charge. I can even go back here and say this here will eventually give me what? This, if that H plus falls off, then I'll be left with this structure. C double bond O, 1, 2, and 1, 2. And H plus will fall in that case. Then here, this is Me, this is Me or CH3, Me, this is Me. Then here, I have generated acetone as my what? As my starting material. This will be my starting material. And then this one, it is logical as a what called like as a retrosynthesis, right? Now, what about that Me there, right? That Me must have come from where? It must have come from something like this. CH3 bonded to MgX, for example. Then that gives me a greater agent. Remember, this one, it's positive. This one, it's negative. Remember the principle of Umpolog back in your elementary chemistry. So, where must this one have come from? Right? That one, it must have come from your methyl halide, for example, which you treated with what? With magnesium in dry, what called like ethyl ether. I'm just making an example, right? So this is my retrosynthesis here, and this one here as retrosynthesis, it is logical. It is logical for me to take this one, but remember, right? We said there are what? Considerations, right? Whenever we are pursuing what? Retrosynthesis, right? Generally speaking, you will look at the design of this reaction itself, the time it takes for this reaction to take place, and then the cost, right? Okay, and then also, not only that, there's the question of simplicity, right? Is this a complex reaction? Is this a simple reaction, right? Generally speaking, like your greater reagents are not easy to work with. They are nasty type of what called like reagents. I'm just giving an example, like as what called like as an organic chemist. So all of those considerations, they come into feature when it comes to what? When it comes to retrosynthesis, right? I will see you in the next class. Remember, organic chemistry is easy, organic chemistry is beautiful, organic chemistry is fun, and you can do it. Don't fear, don't fear, don't fear. Let us do this together. Thank you very much.